Welcome to the deep dive. Today, we're pulling back the curtain on something you probably use constantly, maybe without even thinking about it: digital signal controllers, DSCs.
That's right.
They're not just some obscure tech jargon. These are, well, vital little powerhouses. They're inside your phone, your smart speakers, maybe your car, definitely in factories, driving real-time precision.
The hidden engines, in a way.
Exactly. So our mission today, we're going to unpack the global market for these DSCs. We've got the data where it was in 2021, where it's projected for 2025, and the big one, where it might land by 2033.
And this is all based on official figures, solid data.
Yep. It tells a fascinating story about, well, digital transformation.
It really does. And understanding why this market matters, it's crucial. These numbers, they show technological evolution, how these components are getting adopted everywhere. But maybe just quickly, what is a DSC compared to, say, a standard microcontroller or a DSP?
Good point. Clarification helps.
Right, so think of it like this. If you know about microcontrollers, MCUs, they're great for control tasks, like managing a motor or reading sensors. Then you have DSPs, digital signal processors, which are math wizards, really fast at complex calculations like filtering audio or video.
Okay.
A DSC. It basically smashes those two together. It gives you the real-time control of an MCU and the heavy-duty math capabilities of a DSP, all in one chip.
The best of both worlds.
Precisely. That's why they're perfect for things needing instant, complex decisions and actions, like advanced motor control, power conversion, things where you need both brains and reflexes, digitally speaking, and often on a tight power budget too.
Got it. That really sets the stage for why they're becoming so important. So let's get into those numbers. The global picture first.
Yeah.
Back in 2021,
Yep.
the market was valued at, let's see, $8,695.5 million.
Yep.
Just under $8.7 billion.
A solid base.
Then, looking ahead to 2025, the projection jumps to $11,283 million. Almost $11.3 billion.
Okay, nice steady climb there.
But here's where it gets really interesting. The forecast for 2033, it's projected to hit a massive $18,997 million, nearly $19 billion.
Wow, that's more than double the 2021 figure over, what, 12 years?
Exactly. That's not just incremental growth. That feels like a fundamental shift. What's driving that sustained, almost exponential rise?
Well, the key metric here is the compound annual growth rate, the CAGR. It's forecast at 6.729% over that whole period, 2021 to 2033.
And for listeners, CAGR means it's growing on top of the previous year's growth, right? Like compound interest.
Exactly. It shows a strong, consistent underlying trend. And this growth, it's not by chance. It's fueled by complexity. Our devices, our systems, they just keep getting smarter, needing more precise control, faster processing.
Like in cars, the ADS systems.
Perfect example. Or robotics, smart grids managing energy, even sophisticated medical devices. They all demand the DSC hybrid power control and computation instantly. So yeah, the demand is just surging across consumer electronics, automotive, industrial automation, telecom. But the big question then becomes, okay, where is this growth actually happening? Is it even everywhere?
Right, let's break it down regionally. Let's start with North America, always a major tech hub.
Good place to start.
So in 2021, North America brought in $3,286.9 million. That's projected to grow to $4,191.63 million by 2025, and then reach $6,819.91 million by 2033. The CAGR there is a solid 6.273%.
Still very healthy growth.
And within North America, no big surprise, the U.S. is the giant. It goes from $2,718.27 million in 21 up to $5,567.09 million in 33. That's a 6.155% CAGR.
Okay, so the U.S. anchors it, but what about Canada and Mexico?
Yeah, interesting there. Canada actually shows a slightly higher CAGR, 7.109%, going from about $306 million to nearly $700 million.
Oh, interesting.
And Mexico is very consistent too, 6.454% CAGR, climbing from roughly $260 million to $556 million.
So it's pretty broad-based strength in North America. It's not just like general tech enthusiasm driving it. It's probably specific sectors.
You think? Like what?
Well, you've got aerospace and defense, a big user of high reliability components, advanced medical tech, and just that constant churn of innovation in consumer electronics, things that really need that specific DSC performance.
Makes sense. Okay, let's hop across the Atlantic, Europe. What's the picture there? Feels like industrial applications might be a big driver.
That's often the case, yeah.
All right, so Europe. In 2021, it was 2,339.09 million, projected to hit 4,882.22 million by 2033. That's a CAGR of 6.371%. Pretty similar to North America's overall rate.
Steady progress.
Key players. Well, the UK is significant, expected to grow from $353 million to about $765 million.
Oh, okay.
And Germany, you mentioned industrial, it really shows here, projected to reach over $1,035.03 million by 2033, up from $460 million in 21.
Right. And look at Germany's CAGR, 7.082%. That's impressive.
Higher than the European average.
Definitely. And that screens Industry 4.0, doesn't it?
Yeah.
Smart factories, automation, robotics. DSCs are absolutely vital for coordinating all that complex machinery in real time. It's the heart of modern industrial control.
So Germany's a standout. What about others? France? Italy?
Yeah, they're significant too. France is projected to go from about $341 million to $674 million. Italy from $225 million to $450 million.
Okay.
Spain's also showing solid growth, $171 million up to $370 million. And Sweden, another strong industrial player, $131 million to about $280 million with a 6.57% CAGR.
So a lot of consistent growth across the board.
Exactly. Even the smaller European nations, they're mostly expanding in that 4.6% to 6.7% CAGR range. It signals this widespread push for industrial modernization, plus automotive tech advancements, driving DSC adoption pretty much everywhere in Europe.
Okay, so North America and Europe, solid, steady growth. But if we're looking for, like, the real engine of growth, the place where things are accelerating fastest.
You're thinking Asia-Pacific, aren't you?
You read my mind. That's where the numbers get really eye-popping. Okay, Asia-Pacific. 2021, it stood at $1,782.58 million.
Right, smaller base than NA or Europe back then.
Smaller base, but look at the projection for 2033, $4,407.29 million. It's set to nearly triple.
Wow, okay, that's major acceleration.
And the SecGAR tells the story.
Let me guess. It's higher than the others.
By a good margin. The highest regional SecGAR, 7.843%.
Okay, 7.84%. That really is the global growth engine. So who are the key players driving that kind of number? It can't be just one country.
Well, China is definitely leading in terms of sheer volume, growing from about $528 million in 21 to over $1.3 billion by 33. That's an 8.046% CAGR.
Huge market, huge growth. Expected, perhaps?
But then look at India. This is fascinating. Driven by rapid IoT adoption and a booming auto sector, India is expanding from $264 million to $714 million by 2033.
Okay, solid growth.
At a staggering 8.661% CAGR.
Whoa, 8.66%. That's one of the highest rates globally for any significant market, isn't it?
It really stands out. Huge potential being unlocked there.
Absolutely. And connecting that to the bigger picture in APAC. It's not just China and India, though they're massive. You've got Japan climbing from $310 million to $717 million. South Korea, $160 million, up to nearly $370 million. Yeah. And then there's Singapore. Smaller market, but look at its growth rate, 8.223%. Just $55 million in 21, projected to hit $143 million. Probably linked to their Smart Nation initiatives.
Makes sense. High-tech focus.
And don't forget Southeast Asia as a whole region. Revenue jumping from $123 million to $327 million. That's a CAGR of 8.477%.
Another hotspot within the hotspot.
Exactly. Plus Taiwan, Australia, the rest of APAC. They're all showing strong growth, mostly between 6.6% and 7.7%. So yeah, it's undeniable. Asia-Pacific is the core driver, fueled by manufacturing, yes, but also massive digitization, new tech adoption across the board.
Incredible momentum there. Okay, let's round out the globe. South America, what's happening there?
Still seeing solid growth, actually.
The numbers, valued at $556.5 million in 2021, and it's expected to more than double, reaching $1,257.98 million by 2033. That's a CAGR of 7.019%.
So faster growth than North America or Europe on average? Interesting. Brazil's the biggest player there, I assume.
It is projected to grow from about $230 million to $512 million. Yeah. And Argentina also shows really healthy growth, a 7.52% CAGR, going from $106 million to $253 million.
Nice. And beyond those two?
Chile, Colombia, Peru, they all show good promise. KGRs mostly in the 6.4% to 7.3% range.
And the driver there, is it similar to other regions?
Seems like it's heavily linked to digitization efforts, particularly in automotive production and upgrading industrial controls. Modernization is key.
Right. boosting efficiency and precision. Makes sense.
Yeah. Next up, the Middle East. Market stood at $443.5 million in 2021. It's projected to surge to $991 million by 2033. AGR there is 6.915%.
So again, quite strong growth.
Right.
Saudi Arabia leads in volume, $117.5 million, rising to $265 million.
Okay.
But the UAE shows particularly strong growth, from $68 million to $165 million, marking a 7.618% CAGR.
Nearly as high as some of the APAC countries. That's likely tied to their big national development plans, right?
Yeah.
Smart cities, economic diversification.
Exactly. It requires advanced tech like DSCs. Finally, let's look at Africa.
An emerging market for this tech, definitely. The continent's DSC market was about $287 million in 2021, projected to grow to $638.5 million by 2033. The CAGR is 6.285%.
So mirroring the North American growth rate, roughly. Which countries are key there? South Africa?
South Africa leads, yes, growing from $115 million to about $273 million.
Ah.
And Nigeria is also significant, forecast to grow from roughly $48 million to $110 million, with a 6.511% CAGR.
And the drivers in Africa? Probably industrialization, maybe telecom infrastructure build-out?
Seems likely. Plus a growing, though still developing, automotive sector in some parts.
Right. It covers a lot of ground.
Okay, so we've circled the globe, we've seen the numbers, the TGRs. What does this all boil down to for you, the listener, trying to really get a handle on this?
Well, the big takeaway.
It seems clear the digital signal controller market is on a path of really sustained significant growth pretty much everywhere, right? Averaging nearly 6.73% globally.
Absolutely. From the established hubs like North America and Europe to the real powerhouses of growth like Asia Pacific, these DSCs are becoming fundamental. They're the silent architects, like you said earlier.
Indispensable.
Totally. And if you connect this to the bigger picture, it means this sector is just ripe with opportunity for innovation, for investment, for companies looking to expand. The data isn't just numbers. It really maps out the direction technology is heading towards: more digital control, more precision, more intelligence embedded everywhere.
It's not just about more chips, it's about smarter systems.
Exactly. Making everything more efficient, more responsive.
So here's something for you, the learner, to think about. We've seen these diverse growth rates, especially the high rates in places like Southeast Asia or India. We know DSCs blend control and computation. So beyond the obvious sectors like automotive and industrial automation, what specific, maybe niche, emerging tech trends do you think are uniquely positioned to really take off by leveraging DSCs in those specific high-growth regions? What needs that unique blend? That's a great question to ponder.
Something to mull over as you start noticing these digital signals working silently all around you, shaping what's next. Welcome to the Deep Dive. We're here to pull back the curtain on some pretty crucial tech that often works unseen. The silent architects, if you will, behind the real-time responsiveness of so much modern technology.
That's right.
Today, we're diving deep into digital signal controllers, DSCs for short. Now, they might not always be in the spotlight, but trust me, they are absolutely everywhere. They're making your devices smarter, faster, and incredibly responsive.
Yeah, you interact with them constantly, probably without realizing it.
Exactly. So our mission today is to unpack this fascinating world of DSCs. We want to understand their unique role and explore the market dynamics and some really groundbreaking future trends that are propelling them forward.
It's a rapidly evolving space.
So just to kick us off, lay the groundwork. When we talk about a digital signal controller, what exactly is that?
Okay, yeah. What's truly fascinating here is that DSCs are, well, a unique kind of silicon brain. It's a hybrid.
A hybrid.
Yeah, imagine you're trying to conduct a really complex orchestra. You need the raw power to process every single note, every nuance of sound. That's kind of like your digital signal processor, the DSP part.
Okay, processing muscle.
Right. But then you also need the precise control, right, to tell each musician exactly when to play, how loud, for how long. That's more like your microcontroller, the MCU part.
Got it. Control and timing.
Exactly.
Yeah.
So a DSC, it's basically the conductor that masterfully blends both roles. It brings together that real-time computational muscle of a DSP with the versatile control capabilities of an MCU.
Ah, okay.
And this duality, this sort of seamless integration on one chip, that's precisely what gives them their immense power in today's embedded systems.
I love that analogy, a silicon conductor. So these DSCs, they're not just powerful, they're fundamentally designed to bridge that gap between processing raw, often really complex data, and then actually controlling something based on that data.
Sorry.
So Why the big surge? Why are we seeing such an explosion in demand for these hybrid chips right now? What critical bottlenecks do they solve that, you know, separate DSPs and MCUs might struggle with?
Well, the primary driver is the accelerating need for high performance, and this is key: deterministic embedded systems.
Deterministic, meaning predictable, reliable timing.
Exactly. When you try to pair a separate MCU and a separate DSP, you often run into communication bottlenecks. There's latency, complex integration challenges because they often have separate memory spaces, separate processing pipelines. It gets messy.
Right, data has to shuttle back and forth.
Yeah, and that takes time. A DSC, though, with its unified memory architecture and tightly integrated peripherals, it virtually eliminates those data transfer latencies.
Okay.
And this isn't just, faster in general. It enables a whole new class of deterministic real-time control that was previously just impractical or way too costly.
So it opens up new possibilities.
Absolutely. Think about applications like advanced power conversion, intricate motor control systems, complex sensor interfacing. Industries like automotive, industrial automation, medical electronics, they rely on DSCs precisely because they offer that superior computational performance and critical responsiveness all on the same chip. It lets them build systems far more intricate and time-sensitive than ever before.
That deeper insight into the unified architecture, that makes perfect sense.
Mm-hmm.
So they're not just stepping in where, say, basic microcontrollers or even separate DSPs can't quite keep up. They're enabling a whole new level of real-time precision.
That's a great way to put it.
Now, let's look ahead a bit. What are some of the key growth drivers? What's pushing DSCs into even greater prominence on the global stage?
One absolutely critical area, and it's huge, is the global shift towards renewable energy and smart grid technologies.
Okay. Big topic.
Massive. DSCs are foundational here. Think about solar inverters, wind turbines, those complex grid-connected power converters.
Right, the hardware managing the power flow.
Exactly. These systems need to manage highly dynamic voltage, frequency, power loads, all in real time. They often have to react in microseconds to ensure the system stays stable and to optimize energy efficiency.
Microseconds. Wow.
Oh, yeah. A sudden cloud cover over a solar farm, or a gust hitting a wind turbine, or a big load switching on somewhere.
Yeah.
It requires instantaneous adjustment. The DSCs are the brains performing those critical calculations and making those adjustments to keep the grid stable and efficient.
So it's vital for grid stability.
Absolutely vital. This capability is crucial for, the world's commitment to sustainable energy.
So they're not just making individual devices smart, they're actually helping stabilize the very infrastructure of our future energy system.
Yeah.
That's a huge impact.
It really is.
What else is powering their growth?
Another really powerful driver is the ongoing advancement in motor control technology.
Okay, motors.
Yeah, everything from sophisticated robotics and agile drones to the rapidly expanding electric vehicle market and even modern HVAC systems. Precision motor control is just paramount.
And DSCs are good at that.
Extremely. That integrated pulse width modulation, the PWM modules we often see on DSCs, that isn't just a feature, it's kind of a game changer for motor control.
How so?
Well, by having those modules directly on the DSC, tightly coupled with the processing core, you get microsecond level synchronization between the signal processing figuring out what the motor should do and the physical motor actuation actually making it do it.
Very tight feedback loop.
Incredibly tight. This allows for really fine-grained control, optimizing torque and efficiency, even when the load conditions are changing rapidly. Imagine a robotic arm precisely placing some delicate component, or maybe a drone maintaining perfect stability in gusty winds.
Yeah, I can picture that.
That's the kind of control where speed, torque, and efficiency are absolutely non-negotiable, and it's where DSCs really excel.
It sounds like they're the silent choreographers behind a lot of the sophisticated, precise movement we see and maybe take for granted in the world.
That's a good description. Choreographers.
But, no technology is without its hurdles. For something this powerful, what are some of the roadblocks? What challenges is the DSC market currently navigating?
That raises a really important point about widespread adoption. One significant challenge is the inherent complexity of programming and integrating these systems.
The software side.
Exactly. To truly unlock the capabilities of a DSC, developers really need a dual expertise. They need proficiency in both the complex algorithmic world of DSPs and also the hardware interfacing control-oriented world of MCUs.
Two different skill sets, really.
Often, yeah. Even different ways of thinking about problem solving. And finding developers with this combined mastery it isn't universally easy.
So there's a talent gap.
There can be, yeah. And this talent gap can certainly hinder broader adoption, particularly for companies, maybe smaller ones, with more limited embedded software resources.
So it's not just about the hardware itself, but having the human capital, the expertise needed to really make it sing. That's a real barrier.
It can be, definitely.
But beyond the talent, I'm guessing there's also maybe a significant cost barrier here. Almost like needing specialized tools for I don't know, a bespoke engine. Am I on the right track?
You're absolutely right. The initial cost for development and prototyping can indeed be quite high.
Okay.
Building DSC-based systems, it requires a notable investment. You need specialized development tools, sophisticated simulation software, often comprehensive training.
Not just your average coding setup.
No, these aren't generic programming environments. They're often highly optimized tool chains, really designed to squeeze every last ounce of performance out of these hybrid architectures.
Right.
And while larger companies might absorb these expenses more easily, they can be prohibitive for smaller companies or startups, especially when, maybe a simpler, lower-cost microcontroller might just suffice for very basic application needs.
So it limits penetration in some markets.
It does, yeah, particularly in certain price-sensitive segments.
Okay, so we have complexity and cost. Are there any fundamental physical or engineering challenges that designers face when working with these high-performance components?
Yes, definitely. Thermal management and power consumption are ongoing engineering challenges.
Heat and power. Classic problems.
Always. In performance-intensive applications, DSCs they're prone to heat buildup. It's because of their compact designs and the sheer amount of processing workload they undertake.
Makes sense. Lots of work in a small space.
Exactly. And this isn't just about making the chip feel hot to the touch. Overheating can lead to reduced reliability or even outright system failure.
Which you definitely don't want in critical systems.
Absolutely not. So maintaining system reliability while effectively addressing these thermal issues, maybe through clever cooling solutions or intelligent power management techniques, it remains a significant design concern. It demands continuous innovation from the manufacturers.
Fascinating. So we've got this incredibly powerful technology, but it definitely comes with its own set of complexities, talent, cost, physics that need to be mastered.
That's the engineering trade-off, right?
Right. But despite these challenges, the market is clearly evolving and at a really rapid pace. What are some of the most exciting emerging trends that are shaping the very future of DSCs?
Okay, yeah, this is where it gets really interesting. One of the most transformative trends, I think, is the integration of AI and edge intelligence directly onto the chip.
AI on the DSC itself.
Yeah. Modern DSCs are increasingly being equipped with specialized AI accelerators, sometimes called NPUs, and built-in machine learning support.
So it's not just sending data to the cloud for AI processing.
Exactly. This enables things like real-time anomaly detection, adaptive signal control, sophisticated predictive analytics, happening directly within the embedded device itself. No cloud latency.
Wow. Examples.
Oh, think about an industrial robot predicting a component failure before it actually happens. Or maybe a smart grid automatically rerouting power based on real-time demand patterns detected locally without waiting for a central command.
That's a big deal.
It's profoundly revolutionized its applications in areas like smart meters, predictive maintenance systems, and a whole wide array of industrial automation.
Okay, AI at the edge, powered by DSCs. That's incredible, bringing intelligence right down to the device level, making real-time decisions. What about the automotive sector? We touched on it earlier. How are DSCs playing into that rapidly changing landscape, especially with EVs and ADS?
Right, automotive. The adoption of DSCs in automotive electronics is another key trend, and it's happening at an astonishing rate.
Driven by EVs and smart car features.
Absolutely. Driven by the swift shift towards electric vehicles, EVs, and the rise of advanced driver assistance systems, ADAS, DSCs are quickly becoming absolutely crucial components.
Where would we find them in a car?
You'll find them in EV charging infrastructure, controlling the power flow safely. Inside the car, they're vital in battery management systems, optimizing charging and range, and also in complex infotainment units, processing sensor data.
So, safety and performance critical.
Totally. Their unique ability to process streams of real-time sensor data while maintaining that deterministic, predictable control, it makes them ideal for these incredibly complex, safety-critical automotive systems where even a microsecond of delay could have serious consequences.
Okay, so vital for making cars smarter, but also fundamentally safer and more efficient. Makes sense. What about the other end of the spectrum, the trend towards smaller, more portable, battery-powered devices?
Hmm.
Are DSCs adapting to that, or is their power just too much for, say, wearables?
No, they absolutely are adapting. That's another major focus. There's a significant and growing demand for ultra-low power and compact DSC solutions, especially for the vast world of IoT and battery-operated devices.
So smaller and more power-efficient versions.
Exactly. Manufacturers are developing really energy-efficient DSCs. They have features like advanced, very granular sleep modes, highly integrated peripherals that just sip power, and incredibly fast wake-up capabilities, so they're ready instantly when needed.
Which is critical for battery life.
Critical. This is essential for everything from wearable tech that monitors your health 24/7 to portable healthcare devices you might carry around, and even the smart home systems, sensors and things that run on small batteries for months or years.
Right.
So it's really a true convergence of high performance with critical power efficiency. It's allowing powerful computation even in the smallest form factors.
What a journey we've taken. I mean, from stabilizing a national smart grid all the way down to providing real-time intelligence for an electric vehicle and maybe even powering your smartwatch. These unsung heroes, these DSCs, they truly are everywhere.
They really are woven into the fabric of modern tech.
So as we wrap up this deep dive, it's just crystal clear that the digital signal controller market isn't just on a transformative path. It's actively driving it.
Mhm.
They're enabling smarter energy systems, they're powering precision robotics, supporting real-time analytics right at the edge of our networks. DSCs seem fundamentally at the heart of this next-generation embedded ecosystem.
Yeah.
They're seamlessly bridging that complex control and rapid processing divide.
Indeed. It's this technology quietly working behind the scenes that's making our world not just more intelligent, but also more responsive, more efficient, and definitely more connected.
So for you, our listener, here's maybe a thought to carry forward.
Mhm.
How many everyday objects around you right now, maybe it's your smart appliances, maybe it's that electric vehicle humming down the street, or even the device measuring your heartbeat, how many are secretly being conducted by these intricate high-performance hybrid silicon brains? They're quietly enabling the seamless real-time interactions that really define our modern world.